Well, let me extend my welcomes. I know you've been welcomed a few times today for coming, but thank you for A, attending, and B, attending our little session here. As you can see up here, my name is Brian Adler, and I'm an architect in a professional services organization. And in that role, I get a chance to talk to a lot of customers. I may have talked to some of you. I don't recognize faces because everybody I talk to is on the phone only in this virtual world of ours, but a lot of our customers I talk to about bringing either legacy applications onto the cloud or new applications that they want to go ahead and get architected on the cloud. And over the last 3 years, our customer base has really grown and migrated from sort of the two guys in a garage kind of startup environment all the way up through now big, large enterprises. You saw some of the customers that Michael Crandall put up on the in the keynote session earlier today. But the most interesting thing is that in the last probably 12 to 18 months, more and more of the customers that I've been talking to are interested in private and hybrid clouds, obviously, and that's what we're all here to talk about today. So what I'm going to talk about today, I'll get to an agenda here in a second, is basically just what we have learned over the last 3 years and last 18 months in particular as far as customers that are onboarding private clouds with us, the things they're looking for, the things they don't think about, the things you want to think about. So a lot of design considerations and just little tips and tricks and techniques and things like that along the private and hybrid cloud path. Okay? So with that said, quick agenda. First of all, I always like to start with definitions. And that's more just so that we're all using the same words to mean the same things, because there's a lot of different definitions out there in the industry for these things. And as I've said in previous ones as well, is that these definitions are kind of my own or the ones we use here in RightScale, so they may conflict slightly with the ones you guys use or have seen elsewhere. So these definitions sort of expire once you leave the room, but at least for the next 45 minutes, this is what we'll be using, okay? We'll talk a little bit about infrastructure evolution, sort of where we started and where we are now. And where we are now is obviously in the cloud, and we'll talk a little bit about, now that we are in the cloud, the private cloud key considerations, how you can go ahead and leverage those things that allow you to cloudify all your assets. We'll talk a little bit about hybrid clouds, and I always spend a little time on this because they mean different things to different people. And a lot of times people think they have one concept in mind and they end up walking away with a very different one. So we'll talk a little bit about that. Use cases, we'll talk about some very common use cases, the ones that we saw 18 months ago and the ones that we're seeing far more commonly today. And then get into best practices for private and hybrid cloud design. And overall design considerations, topologies, things like that. Then we'll talk about hardware procurement, software considerations, implementation details, cloud management. Obviously, you know where we lay on that side of the fence. And then some conclusions and Q&A at the end. And as we go through this, if you guys have questions as we go through, feel free to interrupt. Well, I'll leave plenty of time at the end. Probably run about 40 minutes or so. We'll have plenty of time for questions. But like I said, if you have any as we go through, please let me know. Okay? All right. So first and foremost, definitions for today. Virtualization just at the server level. Obviously, virtualization, you can virtualize a lot of stuff, right? But from a server standpoint, we're just going to talk about basically the division of one physical server, right, into multiple isolated virtual environments, right? So the concept of multiple VMs per node. Probably all pretty familiar with that, right? Private cloud, collection of compute, storage, and network resources for a single tenant. That's the big differentiator in our mind, is single tenant versus multi-tenant. A single tenant, and they're all accessed programmatically via an API endpoint, right? And so by single tenant, it means for your organization or your company or your use or whatever it may be. All your neighbors are people in your group, right? You're not sharing those assets with anyone else or any other organizations. Public cloud, pretty much the same thing, just that it's a multi-tenant environment, right? Like the AWSs and the rack spaces and the soft layers of the world, right? Again, this is a group of resources that you access programmatically through an API endpoint, but the difference being that they are multi-tenant as opposed to single tenant, right? And that's, obviously, we're probably all familiar more or less with that concept. Multi-cloud, and this is where we differ a little bit, these last two. And I think Michael Crandall probably touched on these as well, but multi-cloud, an environment that spans two or more separate clouds, be they both private, both public, or one or more of each, right? And a hybrid cloud is a special case of that, a subset, or whatever the word is, of that, where we have an environment that spans one or more public as well as one or more private, right? So a multi-cloud, you could be in two public clouds. That's not a hybrid cloud in our world. A hybrid cloud is a public and a private, or one or more of each of those, okay? And by far the most common scenario, as you might imagine, is one public and one private. And most of the examples and use cases and stuff we'll talk about today are along those lines. Now that you said that, let's talk about infrastructure evolution and how that differs a little bit. So you'll see sort of my thoughts on that here. Back in the day, right, we had the old school data centers, and we had racks and racks of nodes, and we ran one application per node, and it worked. It was great. We knew it. It was tried and true, and it's one of those things where if you don't know any better, you don't know what you're missing, right? So it's what we had. It worked. It was fine. Over time, the capability of any single node outgrew the needs of any single application, right? Moore's Law, a dude came up with it in like 1965, and it still seems true today, right? You just keep getting more and more compute power. And it's very hard to find an application that can consume all the resources at any particular node. So what you end out with is a lot of idle resources, right? We've seen some customers that have brought some legacy stuff on physical hardware. They have a production database server that's running at 10 to 20% active. So it's 80 to 90% unutilized, right? That's a lot of power that you're paying for that you're not using, right? So virtualization, the early years, allowed the ability to have that many-to-one relationship, right? So you had the servers, many servers per node, if you will. And this was a lot better, right? Now all of a sudden we were able to get, excuse me, more computing footprint, right? More computing power into that same compute footprint, that same space and cooling, et cetera, footprint, right? So that was a lot better. But the problem with that is that you weren't able to quickly provision and manage those, and that's kind of where I'm going with your question. So when cloudification, right, virtualization grew up, we now had this API that allowed me at my desk to be able to access these resources and spin them up instantaneously, as opposed to going and spinning up very specific VMs. And usually that involved the creation of a new VM, for example, might involve a ticket that you had to file with your IT manager. He would then get one with the compute group, and one with the networking group, and one with the storage group, and they would build a new VM for you and then package it up and all that kind of stuff. So where we are now, right, obviously in the cloud world, is now you can go ahead and, through an API, sitting at your desk, you can go ahead and spin up these instances in any of the supported clouds, obviously, in the world. You saw Michael's slide this morning with all those pretty yellow dots and stuff on it, right? So now that we have cloud, right, and we have more and more customers that are thinking about the private cloud, what are some of the things that we talk to them about, some of these key considerations? And you'll hear this first one a couple times today because it comes into play a lot, and that's workload and infrastructure interaction. Applications have different resource needs, right? Something that's a highly intensive database application is going to be very different than something that relies on a Memcached server or as an Apache serving static web files, those kinds of things, right? All apps are different, right? So it's really hard to find two that have the exact same characteristics, if you will. So it's important to choose the right fit for your application and your infrastructure. So for those of you that are familiar with, I'll use AWS because most of our customers obviously are familiar with that, but you're running your server, your server instance in AWS, you're running on an M2 XXL, right? Well, you chose that for a reason, right? You chose that because it had the capabilities that you needed it to have, right? It's no different in the private cloud. You have an application that needs a certain set of resources. Make sure that you have a good fit, right? I mean, you can definitely run compute-intensive applications on lower-end hardware. It just won't be as efficient or as effective as you might want it to be. So when possible, obviously I realize, you know, if this is all the hardware I got and this is what I got to do, well, I don't have many choices. But when you do have choices, you want to try to make the correct fit, the correct selection for that hardware and application interaction. Security, and this is one of the good ones, right? Typically in a private cloud, not always, and we'll talk a little bit about on-premise and co-location and stuff like that, but typically the data is going to be contained within that private cloud. So it never egresses, right? It never goes out in the wild west of the internet, so you're able to really keep your arms around it. And that'll probably allow you to be in compliance with some more strict security regulations, right? So from a security standpoint, private clouds are a real good thing, and some of our customers say, I have to go with a private cloud because I need to meet these particular security compliance regulations, right? Latency. A lot of times the consumers of those resources in the private cloud are close to, geographically close to, or network-wise close to, some direct pipe between you and those resources or whatever, right? So the latency is going to be lower in the private cloud on the most part, right? Not always the case, but on the most part. Definitely related to that is user experience, right? If your users are closer to the resources they're going to consume, their experience is going to be better. They're going to see lower latency and improved response times, right? So latency and user experience very much intertwined. And lastly, you can never forget about the cost of it, right? Operational expenses, typically, and with most of the customers we've seen, on a per VM, per hour basis, you get a reduction in your operational expenses compared to the public clouds. Capital expenses, obviously, a whole nother story. If you got to buy the stuff, it's going to take you a while to earn all that money back, right? If you already have it laying around, then it probably makes an easier sell to whomever you need to sell it to, the concept, right? Okay. So real briefly, a little bit on hybrid cloud. So what happens if your application outgrows your private cloud, right? Well, it's one of those good problems to have probably, right? You had a set of resources and you're consuming them, your application became popular, whatever it may be, and now all of a sudden you can't fit your application into the resources you have available. So what a lot of customers come to us and say, hey, I want this cloud bursting thing that I've heard so much about. And cloud bursting, I kind of described it here, is when your private cloud resources are exhausted, your server tier, and it's typically your application or your web server tiers, will expand into the public cloud to tap into the infinite resources, right? And on paper, it sounds great. And actually, I have a little bit of a diagram. I couldn't squeeze it on the same page, but basically here on the left, you have your private cloud. You run out of capacity, so you have your app servers basically spill out, if you will, into the public cloud. And when you draw it like that, it looks awesome. It makes a lot of sense, right? But the things you don't always think about are these are the 4 yeah buts that I always talk to customers about, right? Yeah, but what about security, right? Well, when you're egressing from your private cloud and the public cloud, almost certainly you're going to be on the public internet at that point, right? You might be in an AWS Direct Connect scenario or one of the software setups where you have this dedicated pipe. So there are exceptions, but by far the rule is, sorry, not the rule, but by far the most common use case is that you're going to have to traverse the public internet, right? And as such, you have to worry about security, right? If those packets are out there unsecured, you might as well assume the bad guys have seen them, okay? Latency that we talked about, right? You originally had this nice, close to home solution, and the latency was nice and low, and now all of a sudden some of your app servers are out there, right? And all of a sudden some of your users are seeing really poor performance, and well, that's because there's a lot more traversals that are needed, right? You're out into the great unknown of the internet at that point, right? The beauty of the internet routing protocol is your packets will get there, but you have no idea what route they'll take or how long they'll take, right? So latency is not something you can guarantee once you egress from your private cloud. Similarly, cost. Bandwidth into most of the public clouds is free, or at least very cheap, if not free, but egress is almost always on a sliding scale. So what I didn't show, I'm going to jump over to this, what I didn't show here, and I should have, is these app servers almost certainly have to connect to the database, right? So this connection from the, on the right side, the connection from those app servers back to the database, you're going to be charged for that traffic as they reach back to your private cloud, okay? And then lastly, the third yeah but is complexity. It's hard to set this up, right? You've got to worry about VPN endpoints or using a VPC and having on-premise hardware and all those kinds of things. It's all doable, right? Do we have customers that are doing this? Yes, we do, right? Do we have many? No, right? Well, do we have customers that come to us saying, this is what I want, and then leave with something else? Yes, by far, that's the most common thing, right? And what we typically see is this last bullet, a lot of words, but basically the gist is we'll have a lot of our customers, and Michael had a slide, and I apologize, I missed the exact numbers, but a big portion of our customers are in more than one cloud, right? A lot of our customers are in more than one cloud. The vast majority of them have multiple applications, but an application is in one cloud entirely. They might have 2 clouds and 50 applications, but every one of those applications in its entirety is contained within one cloud. Very few span multiple clouds. There are exceptions, but they're few and far between, okay? Because of these 4 yeah buts that we talked about. Okay, so I'll talk about 3 use cases. And actually the first one here, you guys probably saw this morning, those of you who went through the keynote, Ryan and Vijay and Yuri, I think, did the the demo. But back in the day, 18 months ago or so, when folks were coming to us, particularly the enterprises with they're dipping their toe in the water for the private cloud, a lot of them went with this self-service IT portal, or what we call the IT vending machine. And for those of you that did see it, for those of you that didn't, this morning, basically the concept is you have a UI that's presented to your end user. There's a couple options, big buttons. You click one of the big buttons, and behind the scenes, using the RightScale server template methodology, right, it'll spin up some server or a server or servers in a 1, 2, or 3 tier architecture, or whatever it may be, using these pre-configured tech stacks. And each of these are siloed environments, right? So I can go ahead and spin up my own LAMP all-in-one. And if I accidentally do a drop tables, I've only affected me. I haven't affected anybody else. And I can go, oh crap, kill that server, click the big red button again, and bring it up again, right? So that was by far the most common for the initial private cloud use cases that we saw. One of the other ones that we see with some customers, and one in particular, is, and this is kind of what we were talking about a minute ago, is scalable applications with uncertain demand. And that's where this customer uses the public cloud as their throw it against the wall and see what sticks kind of thing, right? They have a bunch of apps, they have a bunch of app teams that are developing all this stuff. They throw them out there in the public cloud, and some gain traction with the end user, and some are failures, right? And the ones that are failures, they let them run their course, their natural end of life, if you will, in the cloud, and once people stop using it, they just kill them off. For the ones that do gain traction, right, they see a very predictable, very common growth curve, right? They see this huge uptake, right? They reach a certain point, it falls off a little bit, and then it gets to this sort of steady state for many months at a time. So once it's found this steady state, they have this complex set of migration tools that basically pulls that whole application into their private cloud at once. And they've done, and we'll talk about this again, but it's that workload and workload and infrastructure interaction. They've tuned their private cloud for these type of applications. So they're able to get a huge benefit in operational expenses by pulling them in once it's reached a stability standpoint. They don't have the capacity to handle the peak. They do have the capacity to handle the steady state. And third, and this is the one we see by far the most common now in the last 12 months, and there's a reason for that. If everyone remembers what happened back in April 21st and 22nd of 2011, the great EBS outage of 2011, right, presented itself to a lot of people as all of AWS US East went down, right? And that wasn't the case. But if you were heavily reliant on EBS, it certainly felt like it, right? But what that did to a lot of our customers, they went, oh crud, this really can happen, right? I need to have I need an insurance policy, right? I need an insurance policy. So disaster recovery, or DR, is by far the most common use case that we're seeing for a multi-cloud, hybrid cloud environment at this point. And that's where you have your production environment in one cloud, and your DR environment is set up in a separate cloud. And it varies. Some folks have the private as their primary and the public as their secondary, or vice versa, right? But typically it's one of each. And the most common is what we call the warm DR scenario, which I've tried to draw here. And on the left, you see the private cloud, which is their primary environment. And what you see on the right, and the colors didn't come out as good as I had hoped, but the gray stuff is not running, right? And the blue stuff is. And the blue stuff is just a slave database, and it's attached storage, right? So the warm aspect of it is that there is something running over there, but it's not hot. Not everything is running. So your operational expenses in that other cloud are reduced. You're only paying for the bandwidth between the two clouds. The slave database is per instance hour time, and then whatever storage you have attached to it, right? In the case of a failure, right, the case that your primary environment goes down, you take this slave database, you promote it to master. If those of you who are familiar with the RightScale database manager templates, you're going to know all this stuff, but you promote that slave to master. You go ahead and you launch those grayed out servers, right? We have the beauty of the launch all button, right? You click the launch all, they all take 10 minutes or however long it is to boot up. They automatically, using your write scripts or your chef recipes, connect up to each other, and everything's ready to go in your 3-tier architecture. You switch your DNS over to point to your DR, which is now your main environment, and you're good to go, right? You're up and running again. So that's by far what we see the most common from our customers at this point. And we have many customers that are running something like this. Now, this does have the 4 yeah buts that we talked about, but it's only for one tier, right? There's only that one tier that you need to worry about, which is the master to the slave replicating. And for those customers that are using either MySQL or Postgres, they both have built-in, well, you can compile it in, but built-in SSL replication, so you can use your own self-signed certificate, so there's no cost associated with getting an official certificate from VeriSign or anything like that. So you can do your own self-signed replication, which takes care of the security. You still do have to worry about the latency and the cost, et cetera. But from a DR perspective, having a fallback, it's typically a price they're willing to pay, right? So again, this we see a lot. This we're seeing more and more every day, and we probably have almost a dozen customers that are running some form of this right now. A little bit about design considerations. The first and foremost is obviously, where am I going to put my stuff, right? Where am I going to put my stuff? Where am I going to put my hardware? You can do on-premise, and then you have to worry about, well, I probably should have called it high availability considerations when I said availability, but you have to worry about, do I have the infrastructure in place to handle redundant power and cooling, or do I care about redundant power and cooling? It depends on my SLA to my customers, be they internal folks or external folks or whatever, right? Or do you want to go with a hosted or colo facility, right? The downsides to that, the accessibility of the hardware. If you want to go ahead and add new stuff, you probably have to fill out a ticket or call somebody or buy it and ship it there or whatever, right? You can't just go down into the server room, open it up, and re-rack some stuff. There's going to be probably more latency to end users, right? Because it's not here anymore unless you have a direct pipe. And then you have to worry about security again, unless you have that direct pipe. You've got to worry about the security of the traffic from you to there. Availability and redundancy. The easiest configuration, and for those of you who are familiar with these terms, great. If not, I can delve into them a bit. But basically, if you have a single zone in a single region behind a single API endpoint, you can stand that up really easily and really quickly, right? That's sort of the default out of the box, next installation kind of thing, right? But it's not an HA environment by any stretch, right? That outage of that API endpoint, if the server that API endpoint is running on goes down and the rest of your infrastructure is fine and ready to go, you're not going to be able to get to any of it, right? So you really have that single point of failure that's limiting your ability to get to any and all of your resources. Power issues. If you have power issues that take out a particular rack, and that's your only rack and that's your only zone, well, you've lost everything due to one power issue, if you will. HA of your private cloud requires some more complex configurations, and I have a picture here in a second which hopefully does a better job than I do in words, but what we always recommend is multiple zones. Multiple regions, not always. Very few of our customers are running multiple regions. Most of them have, we always recommend multiple zones, rarely do we recommend multiple regions. Multiple API endpoints, for sure. You want to make sure you have that redundancy at the front end, the ingress point to your private cloud. And then redundant and segregated power and networking, right? You don't want one failed switch to bring everything down, okay? So with that said, on the left, I've tried to show sort of the simple configuration, right? There's the good old internet talking to your cloud controller, which is talking to your single rack of nodes, your single zone, and your storage, right? On the right side, we've got a bunch of load balancers, right? Multiple load balancers, again, in different zones and, in different power and stuff, talking to multiple cloud controllers or API endpoints. And all those are talking to, each of those is talking to all of the available zones and storage configurations, et cetera. So unless you lost power to this entire, region, right? A hurricane took out, whatever area you live in or whatever, you probably have some component of your architecture still up and running, right? So this is on the right side, this is definitely what we recommend to customers if, again, obviously this is much more expensive and much more complex. So, but again, it all boils down to what you can afford, both from a cost perspective, excuse me, and also from an SLA perspective, right? How much downtime can you afford? All right, some more design considerations. We talked a little bit about this one earlier, but the intended workloads and the use cases for those workloads, right? Does the application require HA, or can it be tolerant of services, interruptions in service? And we do see some. If you have an application that's people are using, right? If it's user-facing, it probably needs to be HA, right? It's probably not okay that occasionally you can't get to my service and you never know when that's going to be, right? Maintenance windows are fine, unplanned ones are not. However, if you have a batch processing task, like for example, we have some customers that have a private cloud where they spin up resources at midnight. They have a bunch of jobs that are queued up on their database. These servers spin up, they pull a job out of the database, they crunch some numbers. When they're done, they put their results somewhere and they delete it from the database, right? If I'm in the process of crunching these numbers and I haven't yet deleted it from the database and the power goes out, right? Well, the power comes back up, my server spins up, it goes to the database, gets the same job out, turns on it again, and keeps going. So that is tolerant of service interruptions. That's the exception, not the rule, but just an example of some of our customers that, in this case, they don't have redundant power and networking and cooling because it doesn't really matter to them, right? They have a much more lenient application, okay? Flexibility of the infrastructure, right? Are you using it for proof of concept and test beds? Do you have to tear it down and reset it up a lot? Are you trying, hey, let's try this configuration. Hey, let's try this configuration, right? You probably want to keep a fairly standard, fairly simple network topology, and you also probably want to try to keep it on premise if you can, right? It's going to be a lot harder to go ahead and keep reconfiguring stuff that you can't go down and touch. And we talked a little bit about this too. Does the application require high-performance CPUs? Does it have real high IOPS demands? Or low latency interconnects required? All those kinds of things you have to factor in to what hardware you use and where you put it and how you access it, right? On the hardware side, basically compute, networking, and storage, right? Excuse me, on compute, commodity stuff, right? It's called commodity for a reason. It's cheap, it's readily accessible. If I need to add new capacity, I can call up my Dell rep, have it here tomorrow, and strap it in, and it's good to go. Failed components, you swap like for like, right? It's real easy to use that. But it does somewhat limit the application workloads that you can run, or at least makes them less efficient than they could run, right? You can have high-end and specialized stuff, and that might be required for your intended workload, right? I mean, maybe you need a cluster compute type setup for whatever application you're running, and commodity stuff just isn't going to cut it for whatever reason. It does limit your available options, right? Commodity is, you can buy it everywhere, it's ubiquitous. The high-end stuff, not so much, right? You can only get it from a few places. Definitely increases your cost, right? It is more expensive, and it complicates maintenance, right? It's not an easy swap out, swap in necessarily, okay? On the networking side, basically driven by the topology you want to set up, the latency demands or the latency requirements that you have, and obviously price, it always factors in there too. You want to make sure that you have the right equipment that's up for the job. If you're going to do VLAN separation, you want to make sure you have VLAN aware switches, that kind of stuff. Just sort of the basic things you need to think about. Some of the cloud infrastructure software offerings, we'll talk about some of them in a minute. They now have support for networking hardware devices, the load balancers in particular, right? Like Citrix Cloud Stack. Citrix owns NetScaler. Citrix now owns Cloud Stack. Hey, what do you know? You can throw a NetScaler in the midst of your Cloud Stack and have it work just fine. So if you happen to have a bunch of NetScalers laying around, you can repurpose them, right? So that might help dictate which solution you go with, those kinds of things. And then on the storage side, it's usually a pretty simple decision between performance and cost, right? You know, you can go with the commodity stuff that's cheap, just a bunch of disks you can throw in, or do I need some high performance SSD drives and things like that, right? On the software side, there's basically two main things. The first and foremost in the software world or software side is the cloud infrastructure software, right? And if you hear me say cloud enablement technology, it means the same thing. The marketing folks have trained me to say cloud infrastructure software, but if I slip and say cloud enablement technology, I mean the same thing. But that's the three biggies, obviously, Cloud Stack, OpenStack, and Eucalyptus, and those are the three that we currently have support for within the RightScale platform. Do you go open source or do you go commercial, right? Each of those, OpenStack's a little different beast, but each of those essentially has an open source version that you can get for free. Right, Cloud Stack is now part of Apache. All right, you can also download the Eucalyptus 3. Actually, I haven't done it, but I heard you can download the 3. You could do the 2.0. And the difference is that the commercial version gives you vendor support. Do you want vendor support? Do you need vendor support? On the OpenStack side, it is all open source, but there are companies out there that will install and maintain, and so you can think of it as a commercial version. Granted, you're basically just paying a vendor support for something that's open source, but in practice, as far as you're concerned, the interaction is going to be the same. It definitely dictates and influences your other decisions, right? So you have to, that's probably the biggest area of research that we tell our customers. Make sure you look at all the options and make sure you choose the one that's right for you, because it might limit what you can do in the future, right? Access to those resources. Typically, it's going to be through a web they all have a web interface and they all have an API. The web interface probably isn't going to be used that much by other than your admin, right? Your admin is going to look in and see how many VMs are running, how much capacity is left, are there any failed nodes, that kind of stuff. But as far as your end users consuming these resources, it's going to be through that API. Maybe not directly. Maybe you've put in a shim layer for them to interact with, but basically that shim layer is going to be interacting with it through the API. So make sure the API, research that API, make sure it supports the functionality and has the features that you need it to, okay? And then, like I said, I'm in professional services, not in sales, so I won't do the cloud management full spiel, but you guys know RightScale and you know what we do. So, the cloud management software, be it RightScale or whatever you end up using, hopefully, will abstract the underlying details of those cloud infrastructure offerings. You're not going to care what a volume is, right? You just care that I need storage, and it worries about that for you. It's going to present that consistent interface. So all I have to do is say, spin me up a server, and not worry about what that really means behind the scenes, right? It's also cloud portable. As you heard about all the public clouds that we support and the 3 private clouds, private cloud technologies, you can take the server templates that you develop and you can run it on any of those supported clouds, okay? And then obviously it provides the orchestration tools, the auto scaling and the monitoring and alerting and all that other kind of stuff. The implementation process when it comes time to actually do this, right? The first thing is, where do you get your hardware, right? Do you use the stuff you've already got if you've got stuff, or do you go out and buy new stuff? Obviously, cheaper to use the stuff you have, but that might limit your ability to tailor it to the workloads that you want. So again, you hear the same theme. Make sure you try to fit what you've got with what you want to do, and if not, be aware that it might not be as efficient or as effective as you want it to be. The cloud infrastructure software, like we just talked about, that's going to limit, I don't know if limit is a word, I hopefully use dictate, there you go. That's going to dictate, well, I use both actually. This will dictate a lot of the decisions you can make at that point, so make sure you choose that one wisely. And then the cloud topology, right? How complex do you need it? How complex do you want it? Do you need HA? Do you not need HA? Again, that typically boils down to costs and the SLA that you need to provide to whoever the consumer of those resources are. And then lastly, build or buy, right? You can use your in-house expertise if you have it, and more and more companies are starting to acquire that in-house expertise, or you can outsource it to third parties, and there's lots of third parties, and I'm sure a lot of them are milling around the expo floor out there that'll do this for you. Some of the partners that we have will build using your existing resources. They'll come in, take stock of what you got, and say, this is what I can set up for you. And other partners of ours will basically, you pay them to buy new hardware. They bring it in pre-configured, they slap it in, you put network and power on it, and it's good to go. So it can be anywhere in between, right? Anywhere in between as far as having someone build it for you. The management process. RightScale is big about trying to help you guys avoid lock-in. And that lock-in goes at all levels, not just at the cloud provider level, not just at the Rackspace software, data pipe, AWS, et cetera level, right? But the hypervisor level as well, and the cloud infrastructure software level also, right? So you can run a CentOS image on AWS. You can run a CentOS image on CloudStack with KVM. You can run a CentOS image on CloudStack with Zen. You can run that same CentOS image on Rackspace, et cetera, right? So we've abstracted all that from you, and that's one thing you should probably look for in a management layer is that ability to abstract all those underlying details from you. Obviously, the single pane of glass is nice. You can control all your resources from one place and deal with users and keys and credentials and all that stuff. On-demand self-service provisioning, right? Get that administrative task out of the way. There's no more of this IT admin that you file a ticket with that results in 3 other tickets before everything's up and running, right? And what it allows you to do is focus on your apps, right? Probably what you guys are good at is application development. So you want to make sure that you can spend your time focusing on your core competency and not worrying about the things that you should allow the cloud management platform to do for you, right? Private and therefore hybrid, obviously. The clouds were originally thought of as an academic project, right? For example, Eucalyptus started as basically a graduate project at UC Santa Barbara and evolved from that, right? So a lot of people for a long time still thought of it as that. They thought of it as more of a academic exercise as opposed to something that was really viable for enterprises. But over the last, like I said, year, 18 months, advances in all those software, almost like cloud enablement technology, cloud infrastructure software, and the advancements in the cloud infrastructure software have shown these to be really viable IT delivery models. And we have a lot of customers, big enterprise customers, that are using these technologies to run production workloads. And as we discussed, a lot of considerations come into play here. The design, the hardware, the software, implementation, management, all that other kind of stuff, right? And as I said earlier, the thing I hate is all my things always end on the same note, it seems, is there's no one size fits all. It always depends, right? But do your research. There's a huge toolbox out there. And there's a lot of tools in it, right? And don't just, just because you got a hammer, don't make everything a nail. Look in there and see what other tools are available to build what you want to build, because there are a lot of options, and you're probably going to find what you need to accomplish the task that you guys want to.